Hello and welcome to Linux Astro. This is the wide field equipment setup video that describes what I'm using for the wide field live streams. That is, big bright targets. I'll talk about the hardware and connectivity and try to cover most of the questions you may have in that area. Of course, if I miss a few, you're welcome to ask in the comments or in a chat during the live imaging session. So right to it. Starting at the top in this picture, you can see the Wi-Fi antenna. I'm using Wi-Fi to connect to my Linux desktop or laptop. This setup uses a Raspberry Pi Compute Module 4 with a WaveShare I/O board for the computer that does most of the work. It also has the WaveShare motor hat, which is an additional board in the box driving the DIY focuser. I prefer using the CM4 sometimes over a standard Pi 4 because the power supply to the USB bus is more robust, and because the WaveShare board has 4 3.0 ports instead of 2 each of the USB 2.0 and 3.0 ports. The computer on the telescope is using Ubuntu Mate version of Linux. This setup is also entirely run on 12 volts, so a single switching power supply will power everything, and it's simple to switch to a battery if the AC power isn't available. I use a single port 30 amp supply. Overkill, I know, but the 30 amp supply runs cooler than some of the fully enclosed supplies and has a built-in fan. Perhaps I'll describe it in another video. The DIY focuser is a basic stepper motor with both gear and belt drive reduction connected directly to one of the focus knobs of the telescope. There's a very good indie driver for the WaveShare hat board that drives the motor, written by Kevin Ross. I use a similar setup on the planetary imaging scope, and it has always been both the least expensive component and the most reliable for either scope. Again, something for my future video to-do list. The imaging scope is a Radian Raptor. It's a 4.5 scope at 61mm aperture and 275mm focal length. It doesn't show well in this image, but you can just see the end of the guide scope on the other side of the Raptor. It's a SVbony SV165, which is a good pairing with the Radian Raptor for guiding. The cameras are a cool color QHY183 CMOS for imaging and the ever-popular ASI 120 Monochrome guide camera. That's a very popular guide camera, probably because of its price and the fact that it just works. The mount is an iOptron GEM28EC. So now let's take a look at the connectivity. Okay, this is the basic wiring diagram for the live stream setup. You will see, as I mentioned before, that every device is powered by the 12-volt supply, excepting the ASI guide camera that gets its power through the USB port. The QHY imaging camera also gets some power via USB, but the 12-volt supply is required for the cooling system. I currently run my cooling system at -15 degrees centigrade to help reduce noise in the camera's sensor chip. The focuser motor is connected to a WaveShare motor hat board plugged into the WaveShare I/O board GPIO bus. That's a lot of boards. The hat board also requires a 12-volt supply that it uses to power the motor through a standard 4-wire NEMA 17 motor cable, because it's a NEMA 17 motor. I generally connect to the iOptron mount via Wi-Fi, though I have connected via the USB port through the hand controller, which is not shown here. The Linux indie drivers will connect via wireless or wired with no difference in performance. I prefer Wi-Fi as less wires equals less chance of a tangle. Most of the equipment information for the wide field live stream setup will remain pretty much the same for all of these videos, so I plan to leave this video on its own. After this one, you should look at one of the imaging software setup videos for some of the different imaging packages I'll be using on these evenings. Thanks for watching.